Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good day to everyone. In this video, we continue discuss about application of differential equation. In the previous video, we discussed about application in population growth and also radioactive decay. So this time we discuss another two application of differential equation. There is Newton's law of cooling and also electric circuits. So for the net outcome, of course, we discuss about these two applications. Okay, next, we just straightforward go to the example. So under certain condition, the rate of cooling of an object varies with the difference between the temperature of the object and the room temperature. Given that the temperature of the object at any time T is theta, and the constant room temperature is theta naught, write down the differential equation to describe the rate of cooling of the object. So the differential equation for this situation is this one. So d theta over dt equals to negative k in bracket theta minus theta naught. Okay, because we have to consider the temperature of the object and also the room temperature. So theta naught here represent the room temperature. But before that, we notice that we have negative at the front. So remember, the negative means it is cooling. Cooling means the temperature that is theta is decreased. So let's say the initial temperature is 100, so it is cooling down to be 80 or 50. So that will consider negative at K, means cooling. Okay. And also, as highlighted in yellow there, theta naught here represent the room temperature. Okay. So we have to subtract. That's why it's mentioned about the difference. Okay. We have to subtract the temperature of the object with the room temperature. Okay. So that will be our differential equation. Then we use this one in order to solve the following question. Okay, next, given further the room temperature is 20 degrees Celsius and it's cooling from the initial temperature of 100 degrees Celsius. So first, find the general solution for these differential equations. Okay, remember previously this is the differential equation. So we find out that this one is separable. This one can be bring to the left hand side and this one to the right hand side. And also, given that theta naught is 20, so we substitute theta naught with 20, and then we separate. Okay, we separate between theta and t, and then we can integrate. So 1 over means that the integration will be ln theta minus 20, and then on the right hand side negative kt plus c. Okay, so almost similar like radioactive decay, except the radioactive decay doesn't have initial temperature. Okay, room temperature. Okay, next, initial temperature. Okay, before we go to the initial temperature, let's try to put theta as a subject. So we bring ln to the right hand side, so it will be exponent on the right hand side, and then we split, okay, plus c here, so means that negative kt times ec, right? And then we let a equals to ec, exponent c, so we can put at the front ec will become a, so ae negative kt. And lastly, before we put theta as a subject, try to find out first the value of a, right? So t equals to 0, so t 0, and theta is 100. So we calculate that. So 100 minus 20 on the left hand side, so will be 80. So E0 is 1. So straight away we can find out the value of A is 80. So that our equation, theta minus 20. So substitute A with 80, we already obtained the value of A. Then lastly, we can conclude that the general solution, so theta as a subject, we bring negative 20 at the bracket, so become plus 20. So this would be our general solution for question A. Okay. Right. So that's for question B. If it takes 12 minutes for the object to cool from 100 to 50, find the time taken for the object to cool from 50 to 25 degrees Celsius. Right. First of all, from the first information from 100 to 50 in 12 minutes, we try to find out the value of K. So when substitute T and theta, so 50 theta equals to 80 negative KT, so substitute T with 12. And then bring 80, so 50 over 80. And then bring exponent, so become ln. And then this one already cancel out 0, 0, so ln 5 over 8. And then lastly, bring negative 12, so we can find out the value of K. So the value of K is 0.0392, which is in 3 significant figures. Okay. So after we obtain the value of K, then we can rewrite our particular solution. Remember, after we obtain the value of K, that will be our particular solution. So after this, we want to find out the time taken. So substitute theta equals to 25. So I will use this equation. So previously 50, so this time 25 over 80 equals to E negative KT. And then eliminate the exponent, so left hand side will become ln. And then lastly divide with negative 0.03. So we get the value of T is 29.67. However, this is not our final answer. Remember, the question asks to cool from 50 to 25. This one is from initial temperature, that is 100. So from 50 to 25 means that we have to subtract the total time with the 12 minutes, that is from 100 to 50 degree. So we subtract 29.67 with 12. So we get the actual time to cool from 50 to 25, which is 17.67 minutes. So the answer here quite different from the answer given below here. So we stick with our answer because I already checked. There's no problem with our answer, so we stick with our answer, right? Okay. So now in the next example, we discuss one question about electric circuits. Before that, I would like to remind, in the actual question, the question is not necessarily would be like this. It depends on the differential equation given in the question. So you use the equation given to solve. Okay, it's not limited to this example only. Okay, this is only an example. There will be lots of electric circuit question. It's not limited to this one. Okay, right. So we focus on this question for this example. So here we have L, which is the inductance. The unit is Henry. So we also have current I in ampere, and also we have R resistance in ohms. So remember our previous knowledge in SPM or KH in your secondary school. Okay. So here we notice that we have many variables here. So which one is variable and which one is constant actually? So notice that R is given, L is given, and E is given. So means that this one is constant, constant, and constant. Our variable actually I and also t. Okay, so these two only our variable, our focus. Remember the previous equation using integrating factor. So dy dx plus pxy equals to qx. Okay, so we focus about y and x only. So same also, we only focus about I and t only. The other variable we consider as a constant. Okay, to make it easier for us to solve. Right. So let's take a look what I already. Right. So next step, after we use this equation, we will divide with L. Okay, divide with L, we got this one. And then notice that we already given the value of R, L, and ET. ET actually V in this case. So after we substitute, actually the rest, apart from I and T, the rest will be constant. Okay, so it will be like this. Okay, R over L 12 over 3 is 4, and then ET over L 4 over 3. So remember this equation, compare with our standard form, equals to QX. Okay, similar, right? So that, notice that our PX here is 4. So we use that one to find integrating factor. So remember this time we use variable t, not x, so it. So e exponent integrate of 4d t. Don't forget, this time we use t. So integrate 4 will get 4t. So our integrating factor will be exponent 4t. Right, after we obtain the integrating factor, we will substitute this integrating factor on both sides of the equation. Remember, previous we discussed was 6 steps. This is our first step, standard form. This one second step to find integrating factor. So this is the third step. So substitute integrating factor on both sides of the equation. And then we move to the step number 4. So we rewrite the left hand side into the product rule. Remember the product rule, we have three things. The first one is the notation. So previously ddt, so this one ddx, so this time ddt. And this one previously y, so this one I. And then so this is ix, so this time ix is, sorry, this time it, so e for t. So these three terms that you need to have in the product rule on the left hand side. Right hand side, no problem, we just simplify this one, no other changes. Okay, so this is the fourth step. And then remember the fifth step, we will eliminate the ddt, so we bring dt to right hand side, and then we will integrate the right hand side. So this will be our step number 5. And then we focus to integrate the right hand side here. So integrate exponent 40. So exponent 40 over 4. See, we have coefficient of t is 4. So don't forget to divide with 4. And then this 4 and this 4 we can cancel out. Right? So our answer would be, and then we bring exponent this one to the right hand side. So E40 will be negative 40 on the right hand side. So here we already cancel, so will be 1 over 3 plus c. Okay. Before we expand exponent 40 to inside, so don't forget we still have to find out the value of c. So to find the value of c, okay, we just expand first. Actually, this one is exponent. We have exponent 40 here. So exponent 40 cancel exponent negative 40. That's why we come 1 over 3 only. Okay, so this will happen. And then we substitute initial condition. So when t 0, I also 0. So we get I 0 here, and also t 0. So E0 will be 1. So straight away we find out the value of C is negative 1 over 3. Okay, after we bring 1 over 3 to the left hand side. Right. So lastly, after we obtain the value of c, that is negative 1 over 3, so we can rewrite our equation. So 1 over 3 plus c, so c will be negative 1 over 3, exponent negative 3. So since both here we have negative 1 over 3, so we can factorize 1 over 3. So factorize 1 over 3, so will be 1 minus exponent negative 40. So that will be our particular solution for this question. Okay. Right. So the next question, they ask about what happened for the after t for a long time. So if you notice about the long time means that when t approach infinity. So what happened when t approach infinity? So notice that inside here we have exponent negative 40. So exponent negative 40, the power is negative. So when we rewrite into 1 over exponent 40, so means that when t is very large, 1 over something, means that we want when it approach infinity, means that the whole value here will approach to 0. So in other words, we can conclude that our the exponent negative 40 here will approach 0. So we can substitute 0 here. So 1 over 3, 1 minus 0 means that after the long time, our current would be almost 1 over 3. Right. So that will be our discussion, our example for today. So actually there are another application apart from law of Coulomb and also electric circuit. There is also application in chemical reaction and also law of motion. Okay, about velocity, about the distance. Okay, so that will consider law of motion. So basically for this kind of application, don't worry. You don't need to find out the equation. You just use the equation given in the question. So such as the one in the electric circuit, right? So we just use the equation given and try to integrate and solve to find the general and also particular solution. Okay. So before we end our video today, let's take a look about a few conclusions that we can conclude from this video. Okay, the first one. As I said just now, usually we will use question given in question, except for the very simple cases such as population or radioactive decay. Next, okay, remember the case of law of Coulomb and also in the previous video about radioactive decay. The negative sign at K indicates that the amount will decrease as T increase. Okay, such as cooling cases and also the radioactive for the previous video. And then to find K and T, remember the previous video I said use the equation in terms of ln, but in these cases we still can use the general equation, especially after we already change exponent T into A. Okay, so it also possible. Okay, so it's up to you. You can choose either equation as long as you will get the correct value of K, right? Okay, next for electric circuit application such as the one in our example, usually the equation is not simple like population or radioactive or even law of Coulomb. So maybe you need to use integrating factor in order to solve. It is not separable, okay? And also, especially with the electric circuit and also another application, do not confuse with different kind of variable, okay? What is theta, what is I, R, and whatsoever. So be very careful and read very careful, okay? So try to familiar with each of the variable. Okay, our variable is not limited to X and Y or T. It can be any kind of variable that we can use. So make sure be familiar with them, and please use the variable given in the question to avoid losing mark. This one I already mentioned in the previous video when we discussed about radioactive decay. Initially we use M, right, to represent mass, but in the second example there, in the previous video, we use Q. So make sure you use Q and not using M anymore. If you use different variable than the one in the question, I'm afraid you will lose a mark even though your answer is correct. Okay. And also, like the last example we already discussed, there are also certain questions related to limits. Okay. After t long time, t approach infinity, whatsoever. Okay. And also, in tutorial question, check the tutorial question. There is also a question that requires us for graph sketching. So make sure you read back with what we already learned in the last semester. Okay, don't forget about what we already learned, because later on maybe you have to use the knowledge that you already learned in last semester to solve the question in this semester. Okay. So I think that's all for this video. Thanks for watching. And also this will be our end of chapter 2. Okay, so the next video will be the chapter 3. Okay, we'll start with the 3.1, which is trapezium rule. Okay, so I think that's all for now. Until then, thank you very much. Bye bye.